Today, we're going to explore 5 amazing facts about our solar system, the home of our planet Earth and billions of other celestial bodies. Thank you for watching. Let's begin. Number 5. The size of the Sunday. The Sun is the star at the center of our solar system and the most important source of energy for life on Earth. It is also the largest object in our solar system, accounting for about 99.8% of the total mass. This means if you gathered all the planets, dwarf planets, moons, asteroids, comets, and every other object that orbits the Sun, they would only make up about 0.2% of the total mass of the solar system. How big is the Sun? Well, the Sun has a diameter of about 1.4 million kilometers, or 864,000 miles, which is about 109 times the diameter of Earth. To put it into perspective, you could fit about 1.3 million Earths inside the Sun. The Sun is fascinating, and it's the driving force of our solar system, and we are lucky to have it as our star. This brings us to number 4, a tiny part of our galaxy. Our solar system may seem big to us, but it is actually very small compared to the size of our galaxy, the Milky Way. The Milky Way is a spiral galaxy that contains hundreds of billions of stars and has a diameter of about 100,000 light-years. A light-year is the distance that light travels in 1 year, which is about 9.5 trillion kilometers, 5.9 trillion miles. Our solar system is located in one of the spiral arms of the galaxy, about 26,000 light-years from the galactic center. The solar system has a diameter of at least 287 billion kilometers, or 178 billion miles. If the Milky Way was the size of the Earth, our solar system would be about the size of a quarter. Up next, we have number 3, a system of rings. When we think of rings in our solar system, we usually think of Saturn, the most famous ringed planet. But did you know that Saturn is not the only planet with rings? In fact, there are 3 other planets that have rings: Jupiter, Uranus, and Neptune. These planets are all gas giants, which means they have thick atmospheres and no solid surface. They are also very large and massive, which allows them to attract and hold ring particles with their gravity. The rings of these planets are very different from each other, in terms of their size, shape, composition, and origin. Saturn's rings are the largest and brightest, made of billions of pieces of ice and rock, and they have complex structures. Jupiter's rings are the smallest and faintest, made of mostly dust and small dark particles, and have simple structures. Uranus's rings are the second smallest and faintest, made of mostly ice and rock particles, and they have moderate structures. Neptune's rings are the second largest and brightest, made of mostly ice and dust particles, and have unique structures. Moving on to number 2. Dramatic climates. One of the most fascinating aspects of our solar system is the diversity of the planets and their climates. The planets range from the hot and rocky inner planets Mercury, Venus, Earth, and Mars, to the cold and gassy outer planets Jupiter, Saturn, Uranus, and Neptune. The planets also have very different atmospheres, which affects their weather and temperature. For example, Mercury, the closest planet to the Sun, has little to no atmosphere and experiences extreme temperature variations, from about 430 degrees Celsius, or 800 degrees Fahrenheit, on the day side, to about -180 degrees Celsius, or -290 degrees Fahrenheit, on the night side. Venus, the second planet from the Sun, has a thick atmosphere of mostly carbon dioxide that has experienced a runaway greenhouse effect, which makes it the hottest planet in the solar system, with an average temperature of about 460 degrees Celsius, or 860 degrees Fahrenheit. Earth, the third planet from the Sun, has a moderate atmosphere of mostly nitrogen and oxygen, and a stable climate that supports life, with an average temperature of about 15 degrees Celsius, or 59 degrees Fahrenheit. Mars, the fourth planet from the Sun, has a thin atmosphere of mostly carbon dioxide, and a cold and dry climate that can generate powerful dust storms that can last for months at a time. Mars has an average temperature of about -63 degrees Celsius, or -81 degrees Fahrenheit. The outer planets are much farther from the Sun and much colder than the inner planets. Jupiter, the fifth planet from the Sun, is the largest planet in the solar system. It has a thick atmosphere of mostly hydrogen and helium and a powerful magnetic field, which generates intense storms and auroras. Jupiter has an average temperature of about -145 degrees Celsius, or -234 degrees Fahrenheit. However, as you move deeper into the planet, temperatures rise due to the immense pressure and heat generated within the gas giant. In Jupiter's core, temperatures could be as high as 24,000 degrees Celsius, or 43,000 degrees Fahrenheit, rivaling the temperature at the surface of the Sunday. Saturn, the sixth planet from the Sun, is the second largest planet in the solar system. It has a similar atmosphere and magnetic field to Jupiter, but is best known for its spectacular rings. Saturn has an average temperature of about -178 degrees Celsius, or -289 degrees Fahrenheit, and the temperature also increases as you move closer to the core. Uranus, the seventh planet from the Sun, is the third largest planet in the solar system. It has a thin atmosphere of mostly hydrogen and helium, and a weak magnetic field. Uranus has an average temperature of about -216 degrees Celsius, or -357 degrees Fahrenheit. Neptune, the eighth and farthest planet from the Sun, is the fourth largest planet in the solar system. It has a similar atmosphere and magnetic field to Uranus, but is more active, with stormy conditions and the strongest winds in the solar system that can reach up to 2,100 kilometers per h-hour, or 1,300 miles per h-hour. Neptune has an average temperature of about -214 degrees Celsius, or -353 degrees Fahrenheit. Lastly, we have number 1. Potential for other life. The last and perhaps the most intriguing fact about our solar system is the possibility of life beyond Earth. While Earth is the only planet that we know for sure has life, there are some other places in the solar system that may have the potential for life, or at least the conditions for it. These places are mostly the moons of the outer planets, which are diverse and complex worlds, with some of them having liquid water, organic molecules, and geothermal energy. For example, Europa, one of Jupiter's moons, has a thick ice crust that covers a global ocean of salty water, which may be heated by tidal forces from the mighty Jupiter, as well as volcanic activity. Europa may have hydrothermal vents, which are hot springs similar to those that support life on Earth's ocean floor. Ganymede, another one of Jupiter's moons, is the largest moon in the solar system, and the only one that has its own magnetic field, which may protect it from harmful radiation. Ganymede also has a thin atmosphere of mostly oxygen, and a subsurface ocean of water. Titan, one of Saturn's moons, is the second largest moon in the solar system, and the only one that has a dense atmosphere, which is similar to Earth's early atmosphere. Titan has a surface of lakes and rivers of liquid methane and ethane, and a subsurface ocean of water and ammonia. Titan may have a complex chemistry that could lead to the formation of organic molecules, which are the building blocks of life. Enceladus, another one of Saturn's moons, is a small and icy moon that has geysers of water and ice that erupt from its south pole, which indicate the presence of a subsurface ocean of water. Enceladus may also have hydrothermal vents and organic molecules, which could provide the ingredients for life. These are just some of the examples of the potential for life in the solar system, but there may be more that we have not yet discovered. The search for life in the solar system is one of the most exciting and important endeavors of science, as it could answer one of the most fundamental questions of humanity. Are we alone in the universe? Or are we part of a cosmic community of living beings? I hope you enjoyed today's video and learned something new about our cosmic neighborhood. If you did, feel free to show your support with a like, or by sharing this video with someone else who may enjoy it. I would also love to hear your thoughts in the comments below. If you would like to see more videos like this in the future, feel free to subscribe. Thanks again. Until next time, take care and be well.